Hello, onward and upward precalculites. We're heading into section 1.4, building functions from functions. That Uptown Funk gonna give it to you, oh yeah. I really should play Bruno Mars' song. So this is what this section is about. You're gonna combine functions algebraically. That means add, subtract, multiply, and divide them and find their domains. And we're going to learn about the composition of functions, which you should have already seen in Algebra 2. And let's take a look at what we're doing. So here's the definition of sum, difference, product, and quotient of functions. When you see this notation, f plus g of x, you just add the functions together. When you see the difference notation, f minus g of x, you just subtract the two functions. This means to multiply them. You take your f of x times your g of x, and the quotient is f over g of x, which means you divide both of them, provided that g of x cannot equal 0. Hopefully you know that has to be because you cannot have a 0 in the denominator. In each case, the domain of the new function consists of all the numbers that belong to both the domain of f and the domain of g. They have to overlap. So if you have something thrown out of the domain of 1, you have to throw it out of the combination of the two. So let's take a look at this first one. It says find the formulas for the following functions. Here's our f of x equaling x cubed, and g of x equals the square root of x plus 1. So when you see f plus g, all you do is add them. F of x plus g of x, and f of x is x cubed, g of x is square root of x plus 1, so we will just write it like this. That's it. And then you are going to look at the domain. So you know that underneath this square root it has to be 0 or greater, so it would have to go from -1 to positive infinity, would be the domain. This guy, the domain is -infinity to infinity for the x cubed, but this guy is -1 to infinity, and that's why this domain is limited by that. F minus g, all you're going to do is just subtract the two functions. So instead of a plus here, we're going to put a minus. Domain's going to be the same thing, -1 to positive infinity, because you cannot have a negative under the square root. F times g, we're going to multiply them together, so you'd write x cubed times square root of x plus 1. Domain's going to be the same thing. Quotient 1 you have to be careful with. F over g, we'd have f of x over g of x, so we're going to take x cubed divided by square root of x plus 1. In this case, you cannot have a 0 in the denominator, so our domain is going to change a little bit. It should have a rounded parenthesis for around the -1. So with domain -1 to positive infinity. That's all there is to it, so don't make it more complicated than it is. The last one on your sheet is, for this section, is GG, which was a terrible Jennifer Lopez movie, by the way, but this means G times G. So you're multiplying it by itself, and even though when you square it out you get rid of the square root, you still limit the domain to -1 to positive infinity, from -1 to positive infinity, and that's it. So let's look at this function notation. I am hoping that you know what this f of 9 means and g of 8 means. This is what you're going to replace the x in your function with to find what the output is. So if f of x equals x cubed, f of 9 is going to be 9 to the third power. So you just replace everywhere there's an x with that number. And that's going to give us 729. Bada boom, bada bing. What could be easier? G of 8, we'd have square root of x plus 1. Notice they're color coordinated. So we're going to put an 8 in for x right here and simplify it. So square root of 8 plus 1 is going to become square root of 9, which is 3. And the number shall be 3, and 3 shall be the number. So I'm hoping that you remember that from Algebra 2, the function notation. If you know how to stick it in there, you'll be good to go. Just as you replaced x in both functions with numbers, you could also replace x with another function. Woo-hoo-hoo. For example, g of the function x cubed would replace the x in the g function with x cubed. So here's the example. G of x cubed, instead of being just plain x plus 1, is going to be x cubed plus 1. Do you see how that works? This is actually a composition of a function. So since f of x equals x cubed, we call this a composition of g with f, and it's written GOF, which means g of f of x. If you could follow that, you're going to be easy breezy on this composition. So here's the definition you need to write on your paper. The composition f of g, which is denoted f little circle g, is defined by the rule f of g of x, which means you take a whole function and put it inside f, the function f. The domain of f of g consists of all x values in the domain of g that map g of x values in the domain of f. So in other words, you got to take another look at the domain and make sure it's defined everywhere. So let's do some practice with this. Let f of x equal e to the x. Let g of x equal the square root of x. Find f o g. This means the g of x goes inside the f of x. So if we do this out, f of g of x means f of the function g of x. Notice I'm color coordinating it so you can kind of see. So f of the square root of x, because g of x is the square root of x. So we're going to take in this f function, replacing this x with the square root of x. So it's going to be e to the square root of x. And does that make sense? If it does make sense to you, make sure you ask me tomorrow. So let's do this other one, GOF. That means you're going to take the function f of x and put it in for the x everywhere in the g function. So g of f of x you could rewrite as g and then in the parentheses f of x. F of x is e to the x. So this would become square root, instead of x, it's that whole other function, e to the x. So if you can think of this, sticking it in, sticking it out, I know what you're thinking. Get your mind out of the gutter. See if you can do this one on your own. I would pause the video right here and see if you can do the composition, f of g and g of f. Find the domain and range as well. So pause it right now. Okay, so now we're back. So if I'm doing f of g, that means I'm putting this g function in to the f. G of x is 7x. So I will rewrite this as f of g of x. The g of x is going inside the f. G of x is 7x. So when I look at this f of x, I've got an x cubed and an x. Everywhere there's an x, I'm going to put this whole thing, 7x. So this guy is going to go in for the x cubed and the x. So the x and the x here. So it's going to end up to be 7x quantity cubed plus 7x. Something to be careful with when you cube this. The whole thing goes in place of the x, so you have to cube the whole 7x. 7x times 7x times 7x. So you're going to end up with 343x cubed plus 7x. That's it. Domain, there's nothing that would make that undefined, so the domain is all reals and the range is all reals. Let's do the reverse. So this time we're going to do g of f. So that means we're going to take this whole function and replace x in g with x cubed plus x. So g of f is g of f of x, and we're going to have g of x cubed plus x. And so we're going to take all that whole thing and put it in place of the x over on the other one. So instead of being 7x, it's going to be 7 times this whole kahuna here. So you're going to end up with 7 times the quantity x cubed plus x, which simplifies to 7x cubed plus 7x. Now looking for the domain and range, I notice that I don't have any denominators or square roots, so domain is going to be all reals. And range will also be all reals. It's an odd function, so I know it goes both directions. We are going to do the decomposition, what's called the decomposition, on the next part of the note. So just hang tight there, and I'll see you tomorrow.